You wake up, and for a few seconds, the world you left feels entirely real. Then the details fade, like sand slipping through your fingers. We usually interpret this loss as a biological failure, a moment where the human memory system fails to save the data from the night before. But consider the sheer volume of sensory information your brain handles during your waking hours. Every voice, every moving car, and every word on a screen must be sorted and stored. If the brain tried to permanently hold on to the disorganized, often illogical data generated during dreams, it would quickly face a state of neurological information overload. This rapid erasure helps prevent those fragments from cluttering your conscious focus, preserving your mental bandwidth for the day ahead. For decades, the scientific paradigm was that sleep existed solely to consolidate and protect our memories. It was seen as a period for the brain to hit the save button. However, scientists like Crick proposed a different possibility, that REM sleep is actually a mechanism designed to actively eliminate excess information. Crick, who helped decode the double helix structure of DNA, suggested that dreaming was a way for the brain to unlearn useless connections. While counterintuitive at the time, modern studies on the brains of mice have shown that this theory of active data destruction was remarkably accurate. It turns out that maintaining a sharp mind requires the brain to aggressively and intentionally destroy data while you sleep. This process begins roughly 90 minutes after you fall asleep, as you enter the stage known as rapid eye movement. During REM, your brain waves look almost as if you were awake, but the most distinctive sign is your darting eyes beneath your eyelids. Scientists have recently identified the specific biological agents responsible for the forgetting that happens during this stage, MCH neurons. These cells are located in the hypothalamus, a peanut-sized region deep inside the brain that regulates sleep and appetite. Research shows over half of these MCH cells fire exclusively when the brain enters a REM cycle, remaining silent during the day. The onset of REM sleep effectively shifts the brain's focus, turning it into an active engine for deleting data. These MCH cells bridge the gap between the hypothalamus and the hippocampus, the brain's central storage unit for new memories. When these cells fire, they send inhibitory signals that prevent disorganized dream data from being consolidated into long-term storage. Researchers confirmed this by using genetic tools to turn these specific neurons on and off in mice. When the cells were activated, the mice forgot information they had just learned. When the cells were turned off, the mice showed much stronger memory retention. This physical trimming of neural connections is known as synaptic pruning. By firing during sleep, these neurons regulate the network, trimming back the connections to keep the system streamlined for the next day. This circuit is essential for mental health. When this natural pruning process breaks down, it can lead to severe cognitive consequences. An inability to clear out this neurological noise is closely linked to the progression of memory disorders like Alzheimer's, where the brain is overwhelmed by waste. It is also a factor in PTSD, where the brain's deletion mechanism fails to prune away traumatic or intrusive memories, leaving them permanently vivid. Understanding how this forgetting circuit works is now helping doctors develop new strategies for protecting long-term cognitive health. It turns out that learning how the brain destroys a memory is just as vital as learning how it saves one. So the next time you wake up and feel a vivid dream slipping away, don't worry about your memory failing you. Your brain is simply making an active choice to treat that information as noise, clearing the path for the day ahead. Waking up without those memories is the biological result of a system clearing its desk to make room for the experiences that define your real life.